Welcome back to Further Solutions Academy. Further Solutions Academy. Encourage us more, help us to share our video and also subscribe anywhere you see it. Help us to subscribe if you have not subscribed before. And anywhere you see it, help us to share to your friend. They are lovely video and they are very good. We have over 220 videos present on our platform. It means you can come to this platform and learn any topic of your choice. Don't forget Further Solutions Academy. And also, to reach us, you can reach us with this number 2348034495990. If you have any problem, any complaint, you can call us, and you can also WhatsApp us, and Telegram is allowed. Telegram is allowed. With this is allowed. Okay, I'll be working on circular and simple harmonic motion. It's a very lovely part of physics that you need to understand very well. Now, the outline of this video, which each outline will take me a video of 30 minutes on each. The first one, I will start with circular motion, which is I will talk about the introduction, which is definition and example, and simple harmonic motion, simple pendulum, and energy of simple harmonic motion. By the end of this, you should understand what is called circular and simple harmonic motion. Now, let me start with the first one, which I'll be talking about. What? Circular motion. Circular motion. That is what I'm starting with. I'm starting with circular motion. Okay, I'm talking about circular motion. Now, when we talk about circular motion, we have been talking about motion, I've been on motion all this while. But this time around, we are talking about circular motion. Now, a circular motion, just like we are talking about circular motion, we know what is called circle. It means that motion, it involves moving around the point. is defined, let me call the board, as the motion of an object round a circle, or circular part. That is what is called circular motion. It means that thing move around a circle or in a circular part. We all know what is called simple pendulum. If you draw a pendulum, it move like this. It will be moving on axis. It will be moving on axis. It won't go beyond that axis. Now, that is our motion. But when we get to simple pendulum, we'll more on that. Now, circular part has three basic. An object said to be undergo uniform circular path, which you all know that when moved along a circular path of a constant speed, there must be a constant speed. So, example of it is a very good example. Is our fan. The fan we use in our home, is a very good example of it. And also, let me explain something. Circular. Circular motion has three basic characteristics. That's three basic characteristics. The first one we'll be talking about constant speed. The second one we'll be talking about changing or variable velocity, and the third one we'll be talking about centripetal acceleration or force. Now we can talk about centripetal acceleration, and also we can talk about centripetal force. I will try to expatiate those things now. Very, very important. Now, when we talk about the centripetals, and we have to understand. Now, let me quickly put more light on this. We know what is called constant speed. We know what is called changing or variable of velocity. And velocity change, final and initial, at the rate of changing of velocity. Now, let me quickly emphasize on these two, acceleration and force. Now, when we talk about centripetal acceleration, centripetal acceleration is experienced is experienced by any object undergoing circular motion, or and is always directed towards the center of the circular part. That's what is called centripetal acceleration. Now, when we talk about centripetal acceleration, we are talking about centripetal acceleration, which is, I can call it A equals to velocity squared all over what? All over radius. Velocity squared all over what? Radius. Now, this my V, I can call it speed. Now, once we talk about speed, we are still talking about velocity, because I told you at the beginning when I was talking about force and other things, that when we talk about speed on a specific direction, the term is just referred to what? Velocity. It means when that thing is moving, it has direction because of what? That direction is what? Is embedded inside what? Circle. It means it can't go beyond the circle. It means this velocity also equals to what? Speed. And when we talk about speed or acceleration, or velocity, we all know what is velocity. We're always on meter per second. Now, also we talk about R is always my radius. We know what radius is. Radius, which is my radius, is always radius of the centripetal. Radius of the centripetal part, wherever you can put part. Now, and with this, let me move on to centripetal force. Centripetal force. Once there is centripetal acceleration, and also there will be centripetal force. Now, when we talk about centripetal force, it means is defined as the force that keeps objects, or keep an object moving moving along a a circular path. That is what we mean by what centripetal's force, which is at a constant. There must be a constant at constant speed. Now, it means my force. We all know that my force equals to ma, which is mass times acceleration. It means I can say that my centripetal force equals to mass multiplied by centripetal acceleration. Please, I'm writing acceleration there. That is what we are talking about. It means I can say that my F equals to mv squared divided by what? Radius. That is what we are talking about. Mv squared divided by what? Radius. With this, you can see how it is. Now, let me with what on ground, let me show example, 2 or more example on this part of circular motion. Okay. Now, let me show one of my examples. Now, let me start with example 1. An object of weight 150 Newton moves with a speed of 1.4 meter per second in a circular path of radius 3 meter. Calculate it. Calculate in centripetal acceleration of the magnitude centripetal force, which is G equals to 10 meters per second squared. Now, solution to this problem. If I have this type of problem, the first thing I would do is that I would like to write out what I'm having. The first thing is weight of object. Weight of object, which is W equals to what? 150 Newton, which is my weight. The second one, I will call it speed, or I call it speed or velocity. Anyone you feel like. Which we are talking about V, which is equals to what? 4.5 meters per second. Now, the next thing I will talk about the radius, which is my R, which is equals to 3 meters. Now, we all know that my force equals to weight equals to mg. Now, my force equals to weight equals to mg. I've told you that when we are talking about weight, my weight is always along with what? Gravity. But force is always with what? Acceleration. Now, since once I'm having here, I can say that my mass equals to what? Weight all over what? Gravity. Now, which I can say that 150 divided by 10. Hope you know what I'm doing here. It means my mass equals to 15 kilogram. 15 kilogram. Since I have my mass as 15 kilogram, I can now say that what? Centripetal acceleration. Peter acceleration, which is my A, equals to my centripetal acceleration is always equals to my my V squared divided by what? V squared divided by R. Now we all know that my V is already given, which is 4.5 divided by my R is what? Is 3. Now, which is my acceleration will now be. Now, what will it be my acceleration? My acceleration will be 6.75. 6.75 meter per second squared. Make sure you go along with your what? SI unit. It's very important. Since I have that, I cannot continue by having my centripetal acceleration. I mean, force, which is what I'm looking for. It will be, which is we know as my F equals to mv squared divided by my radius. Mv squared divided by radius, which I can say what is my m? My m is given as 15 multiplied by my velocity is given as 4.5 divided by my radius is given as what? 3. We all know here 1, here what? 5. Which is my force, will be equals to 5 multiplied by 4.5. Now, with the help of my calculator, I will be having, there must be a square here. There must be a square here. Now, with the help of my calculator, I'll be having my force equals to, I'm pressing my calculator anyway, which is I'll be having 101.25 meter per second squared. I mean, Newton. That is my answer. 105 meter per second. Now, with this, can you see it's very simple? It's very, very simple. Let me move on to another example, which is to add to it. Now, I have another question this way. If an object of mass 4 kg goes round a circle of radius 0.5 meter in 3.14 seconds. What is the force towards the center? Toward the center. Taking your pi as 3.142. Let me put this one 3.142. Now, solution to this problem. I have this type of problem and I want to solve it. The first thing I would first note there, the first thing is the force towards the center is the centripetal. The centripetal force, which is my F equals to mv squared divided by what? My R. That is the question you have to find there. Now, the second thing I will look after, the distance round a circle is the circumference. circumference of a circle 2 pi, which is let's take time to take him to undergo round circle is equals to 3.124 seconds. 24 seconds. Now I can ask you what my velocity of object equals to distance divided by what? Time, which is we all know as v. Now with this I can say my v equals to what is my 2 pi, which is the distance, divided by my time taken is 3.142, which I will be talking about what? 2 multiplied by 3.142 divided by 3.142. This will cancel this. Now I'll be talking about what? My v will be equals to 2 meters per second. My v equals to 2 meters per second. I can now continue by having my force. My centimeter force will be what? mv squared divided by my radius. mv squared divided by my radius. It means what is my m? My m is the mass, which is the mass is 4 kg, multiplied by what is my velocity? Velocity is talking about what? 2, which is 2 divided by more 3.1. okay, my radius, what is my radius? My radius is my radius of 1 point. Please check this place. If it's not in, many questions will come in terms of what? Centimeter. You have to convert it. I will make sure I get one that will help us in that part. Now since I have this, it means my f will be equals to what? 32 meter per second squared. 32 meters per second squared. That is my answer. No problem. That is what need to find them. Now let me move on to another problem that can really help us. Now I have this question. A stone of mass 500 grams tied to a rope of 50 centimeters long is wide at an angular velocity of 12.0 rad per second. Calculate the centimeter force. Calculate the centimeter force. Solution to this problem. Now there's something I want to introduce here. What is called my mass is always equals to 500 grams, which I will not use gram because of gram is not allowed. We are talking about rad per seconds, and we're talking about what? Centimeter. You must to convert those things so that you have the SI unit, standard unit. It will be 0.5 kilogram, which is my radius, will be equals to 50 centimeter, which also will be equals to 0.5 meter. Now I'm just converting anyway. Now angular velocity. Angular velocity, which is not linear velocity. The difference between linear velocity and angular velocity. This one is angular velocity. That's why it's attached to what? Rad per second. Rad per second. If it is normal velocity, it will be what? Meter per second. Anyway, now rad per second, it means it will be equals to now it means my it will be equals to angular velocity is always denoted by this. Let me write it again. This is how to write it in an advanced way, even in any level. It means I'll be talking about what 12 rad per second. Now, since I have it this way, I can now say that what my angular linear velocity, which is v, is related to angular velocity, which I'll be, that is to say, my velocity equals to, which is of my r, which my r will be equals to velocity over angular velocity. Now it means what I'm trying to say that my f is equals to mv squared divided by r. Now what is my v now? This is my v. It means my f equals to what? M r squared divided by what? My radius. With what I'm having there, this one, okay, let me just quickly expatiate a bit. My f equals to mass angular velocity squared r squared divided by r, which this r would cancel the r off. Please hope you can understand what I'm trying to say. Mathematics come to play now. Now, since I have it that way, I can now continue by having, what are the things having here? I have my mass. What is my mass? I have my velocity equals to 0.5 multiplied by angular velocity, which is 12 squared, multiplied by my radius is 0.5, which I can say that 1 all over 2 multiplied by 144 multiplied by 1 all over 2. Here, which is 14 here 7 2, and here 7 here is 3, 7 in 12 6. My f equals to 32 Newton. That is my answer. 32 Newton. I mean 36 Newton. That is my answer. That is my answer. Let me give you one more example and go to simple harmonic motion. Now, this example, I have to be very fast. A force which is F is required to keep 5 kg mass moving round its circle of radius at a speed what is the speed of the force is tripped. Now, solution to this problem. Now, I have to be very fast here. The first thing, I have my mass as 5 km, and I have my speed, which is my velocity, as 7 meters per second, and also my radius is 3.5. The first thing I will do is that the force in acting in what is what? As a centripetal force, which is my force, it will be equals to mv squared divided by my r, which I can say that 5 multiplied by 7 squared divided by 3.5, which by so doing that I'll be having 47, which is 70 Newton. I'll be having to. Now, if it is triple now, if the force is tripled, now if the force is tripled, it means the centripetal force which is F, become 3F. It means I'll be talking about 3 multiplied by 70, which I'll be having 210 Newton. Now, 210 Newton. It means my F is equals to 210 Newton, my mass is equals to 5 kg, and my radius is still remain the same, 5 meter, 3.5 meter. It means my force will be equals to mv squared divided by my r, which I'll be having 210 equals to 5 multiplied by v squared divided by 3.5, which I'll be having my v squared will be equals to 210 multiplied by 3.5 divided by 5. Now, since I have it this way, which I'm pressing my calculator, I'll be having v squared equals to 147. It means I'll be having 147. Yes, root the both side. My v will be equals to 12.1 meter per second. That's my velocity. That is my velocity. Now let me take a note. If that is the case, I think that is what we need to get. That is what we need to get. I have to stop here. More example can still come, but if you have any problem, just get back to me. Get back to us. We will surely attend to it. Don't forget, you are home with further solutions academy. Encourage us to share, and please help us to subscribe. Thanks for watching.